This video, we're going to demonstrate the gear generator website and how it can be used to make both simple gear trains and compound gear trains, which we'll need in the mechanisms and structures unit. The link you'll be given for the website will be this specific link here, which will start off with a single gear with 12 teeth rotating at 10 RPM. And that gives you a simple starting point for building all other gear trains. So what we'll demonstrate here, first of all, is what we can do with an individual gear. So we can see when we only have one gear, it's always selected, but two things we'll see when a gear is selected. One, the gear will be in a kind of light blue colour, almost as if it's being lit up on the screen. And on the left-hand side of the screen, there's a white bar highlighting information about our gear. And the information it tells us in that white bar, this is gear number 0. We always start with gear 0. And N12, N means number of teeth, there's 12 teeth here. And additionally, it will tell us a ratio from the gear we're on to our driver gear. Now, since this is our driver gear, the ratio is 1:1, and it also tells us the speed it's rotating at. Now, again, this is the speed that we've set for this gear, but for other gears we don't set their speed. That is determined by the gear train itself. So let's just have a look at some of the controls with a single gear. So up to the top of the screen, a second under animation, we have speed RPM, and if I can change this to 100 RPM and it will spin very quickly. I could change it to 2 RPM and it will spin very slowly. And our range is from, I'm not sure the smallest we can set it, we'll say 1 RPM is the smallest, and 360 RPM is the fastest we can set it to, in a quick demonstration of what that looks like here. We'll never need to use this particular velocity in the course, so we don't need to set things to quite that fast. Although we'll use some faster speeds in the simulations we build, but usually we're sticking to about 100 or 200 RPM at the faster end. But we'll reduce it back to 10 just now so we can see the rotation in action, and also, and that's the speed that the simulation will be running at when you first get it. The next option we have for a single gear is the position, and it's really only the first gear that this applies to in terms of where it is on the screen. On the left-hand side, under connection properties, you'll see that the auto position box has an X in it. If we click this box and move the X, you'll see that two new options light up, X position and Y position. And what these do is allow you to move, using the Y position controls and the X position controls, to move our gear across the screen. And depending on what other gears we're going to have or where we want to position driven gears in this gear train, it might be helpful to us to move this gear about. But if we don't have a particular position we need it in, we can select auto position and the software will automatically place it somewhere in the top left of the screen. For our demonstration, I think I'd like it to be a little bit further down, so I'm going to untick auto position. I'm going to increase the Y position to bring it down here. And the only other control we need for our starting gear is the number of teeth. And it's currently set to 12. I can type a number in this box, but I can also use the plus and minus buttons if I want to increase or decrease the number of teeth. So we'll make a few simple gear trains just now, which appear in the course notes, so you've got them for comparison. So I'll start off with the gear train in figure 3, which you'll find on page 6 of the course notes. So that is a starting point where we have a 12-tooth gear, and meshing with that, we have a 24-tooth gear. So this is the system that will be slowing down. When we want to add a new gear, we just click the Add New button under Gears. Now, when we have multiple gears in the system, we want to make sure we're selecting the gear we want to add the new gear to, but since we only have one gear here, we can click the button. And before we get into building the desired gear train, you'll see that it's automatically added this below on our screen. say that we wanted to build our gear train from left to right. There was no particular reason to do that, but say we wanted to, or it was necessary for the system we're looking at, as it appears on the course notes. Back under connection properties, so that's this section just below our white bar here, we can see we've got an option for parent gear. This is saying which gear this is going to be connected to. At the moment, there's no one choice because the parent gear is our driver gear 0. We've got an option for axle connection, we'll come to that in a second, and there's an option for connection angle. Now, if we want to have our gear to the right of our driver gear, we change the connection angle to 0 degrees. As we increase this, we can move it round in a circle, or we can bring it round the other way, and bring it round in a clockwise direction as well. So the degrees move up in a positive way as it is anti-clockwise, and then move in a negative way. So negative 90 takes us down below where our gear appeared there, and but at 0 we can have it just to the right there. Now in figure 3, the second gear had 24 teeth. Now before I do this, you can see if I click on our starter gear, that lights up and its white bar is selected. If I select our new gear, it's now in light blue, and its white bar says number 1 N13, and it tells us the ratio currently of the driver gear and the current RPM. So there's only one more tooth. It's only going slightly slower than the driver gear. In figure 3, it has 24 teeth. So we'll go into gear properties, put in 24, press enter, and now I have exactly the configuration that we have in figure 3, a 12-tooth driver gear and a 24-tooth driven gear. Now we know this is a 2-to-1 ratio in terms of velocity from the driver to the driven, and we can see that here as well. The white bar highlighted tells us the ratio is 2-to-1, and as expected, it tells us the speed is 5 RPM, which is double the number of teeth, we have the speed. So that's what we have for figure 3. In figure 4, we want to have the same setup in terms of the driver and the driven gear, so we have the same velocity ratio, but in this system we have an idler gear added in the middle. Now there may be a much more sophisticated way to add an idler gear to this system, but I'm yet to find it. I wonder if we could somehow add one to the driver gear and then move this gear over, but rather than mess about with that, I'm just going to select this gear so it's lit up in light blue, and then click the remove button right up at the top where it says gears. Where we added new, we've also got the option to remove, and click remove, and that removes that gear. So I suppose it's important to know about this control. When I add a new gear, again I'll bring it back up to the right, and this time I'm going to reduce the number of teeth to 8. So this is our idler gear from figure 4. I'm going to add a new gear to this. Now this is where again I need to be careful if we're moving about different options. I don't want to add the gear here because that's adding a second one on our driver gear. I want to make sure I've selected the idler and add a new gear. And this time it's chosen, probably to avoid clashing with the driver gear, to add it to the right. And this is where we happen to want it. So all I'll do now is change the number of teeth to 24. We have the same gear we had in figure 3, except now there's an idler gear between the driver and the driven gear. And you can see in the left-hand side of the screen that the white bar highlighting gear number 2 on the gear section. We still have our 2-to-1 ratio. We still have our driven gear speed of 5 RPM, which we want. So all the idler gear is doing is what its required job is. It keeps the driver gear and the driven gear turning in the same direction, and it has no impact on the velocity ratio. That's a couple of things that we can have a look at. I'm going to now give an example of working with a compound gear train. So let's say we wanted to build, we'll do something like a 1-to-6 ratio, but rather than have one gear that has 6 times as many teeth as another, we're going to do this in 2 stages. I'll start off by removing this gear and this gear, And let's have our starting gear have 10 teeth to begin with. So what we'll do, first of all, our objective is to get a 1 to 6 ratio. Now, of course, we could do this. I could add a new gear. I could put it 0 and I could set it to have 60 teeth like this. But you can see immediately the scale of this, depending on what system we're using, this might not be a suitable size of gear. It might be too big for the system, too bulky or too difficult to make. So instead, we're going to start off with a 20-tooth gear as our second gear. So we've achieved so far a 2-to-1 ratio, which is not quite what we're looking for. We're looking for 6-to-1. We want a reduction in speed by a factor of 6, but we've got a factor of 2 so far. But this is where the compound gear train comes in. To this gear, the second one I've added, I want to add a new gear. But rather than have it continue as a simple gear train, this is where the option for axle connection comes in. Under connection properties on the left-hand side, I can tick the box axle connection, and it puts our new gear on the same axle as our second gear. So this new gear is also turning at 5 RPM. Now I want to achieve a 3-to-1 ratio between this new gear and another gear I want to add to it. So let's make this an 8-tooth gear, and to this gear, remember, make sure the right gear highlighted. So this new small 8-tooth gear, I'm going to add a new gear. I'm going to make this a 24-tooth gear. The reason I'm picking 24 is because 24 divided by 8 is 3. And this means I have a 2-to-1 ratio, so our driver gear and the first gear it meshes with. And on the same axle as that first gear, I've now added an 8-tooth gear, and to that I'm meshing a 24-tooth gear. So I've got a 2-to-1 ratio and a 3-to-1 ratio, and of course 2 times 3 is 6. And if we weren't sure we got that right, we look over to the left-hand side, and the white bar highlighting the information about gear 3 tells us its ratio to the driver gear, that's our left-hand most gear, is 6-to-1, and its speed is 1.67 RPM, which is of course 1/6 of 10 RPM. So we've got our reduction in speed by a factor of 6 as we were looking for here. So this is how we build a compound gear train. And once we've built this, we could vary anything else we wanted. So say we had wanted to build up a 9-to-1 ratio. Well, if I take this input gear here at the beginning, I'll select gear 0, reduce the number of teeth to 8 on that one. I'll take gear 1, increase the number of teeth to 24. Well, I've got a 3-to-1 and then another 3-to-1 on the same axle. So I've got 3 times 3. And we can see over here, if I select gear 3, a 9-to-1 ratio. So by controlling 2 gear ratios between the driver and the gear it meshes with, and then the gear that we place on the same axle as that second gear, so I'll highlight this gear here, and then another gear it meshes with, we get 2 velocity ratios which we can multiply and use to create a much bigger effect in terms of velocity. The same is true in reverse as well. If the driver gear is bigger than the gear it's driving, we can get the same factor increasing velocities. In fact, I'll very quickly do one of those. Let's reduce this now. We'll do the opposite actually. Let's make this an 8-tooth gear. Let's make this, try and do this without messing up, an 8-tooth gear here. Make gear 2 24-tooth gear, and gear 1 I'll do that one, 8-tooth. Gear 0 and make 24-tooth. So what we've got here, that was maybe more confusing than intended. We have a 24-tooth gear being our driver gear, turning an 8-tooth gear, so it's increasing its speed by a factor of 3. On the same axle, I had another 24-tooth gear, turning another 8-tooth gear. So we now have a 1-to-3 and a 1-to-3, giving us a 1-to-9 ratio, meaning this right-hand output gear here that I've highlighted just now is turning 3 times 3 times faster than our input, so an increased speed of factor of 9. So we can do the same with compound gear trains. It's not just about slowing down. We can use two velocity ratios and speed things up as well. And of course, you could combine a speeding up and a slowing down, but we wouldn't really encounter that in this unit. And it'd only be a very specific circumstance we'd be interested in something like that. The last thing to say, when you're saving your work, there's two things to do. One is always take a screenshot of your work just in case you lose anything. The second thing is go up to the top of the screen and copy the URL that's at the top, copy the website link. What you may have noticed as I've been making changes is that the web address at the top of the screen changes as well. So whatever you have at the top there, that will be a specific web address that will take me to the exact gear system that you've built, so that I can see your exact work. But a screenshot's always a sensible precaution because you never know, things can always go wrong. That's how you use Gear Generator. Hopefully that explains all the features you're going to need to use, but please do get in touch if there's anything else you want to check before you submit your work.